All right, so we are back to this part, the JZ, JNZ, JGE, and JCC. So these are going to be the jumps from the assembly code. So now JZ is jump if zero, JNZ is jump if not
Jump if
zero,
not zero.
hmm
Yeah.
and JGE is jump if signed greater or equal to. And we have something called JCC, which is hmm, I see jump if carry set, flag set, but I'm not sure what a CC is. I don't even see it from the
I'm
assembly. Do
gonna
you guys
I'm
see it?
gonna I'm gonna check. I did just recently. Huh. Let me check. Right, minimize. Minimize and Okay, hold on. Let's see. That's interesting. So I'm even just looking at the full book. The JCC instructions are not one particular instruction, but rather a series of conditional jumps. The conditions may vary with the instructions used. JCC instructions. This is just from that reading material, reverse engineering code. It's
Hmm.
like um on page 44, I just searched JCC. Yeah, and it says destination operand REL8, source operand NA. So this is just like trying to find out if we got on any kind that
Mm-hmm.
reverse engineering lab
Book.
one thing.
Yeah.
No, I was just looking at the actual book that he sent us. So that was on, it says JCC instructions are not one particular instruction, but rather a series of conditional jumps. Um, but it might be in some of the other material, but this is just me opening that kind of PDF IDA or the
Yeah.
reverse engineering book. So it
Hey,
might
for
be
my
some.
I have a question. For my other Zoom recording, I can send it to each of one of you guys' emails. Like not the whole class, but if they want it, you can just ask them if they need it. So yeah. That's
Okay.
yeah, I'm gonna send it to Neil, Trevor, Wesley,
Do you want me to
Riley
put
as well.
my email in the chat or is
Cool.
everybody there?
Yeah, because I don't understand why it's not working from there. But I'm gonna send it to you. I'm gonna send it to Trevor so he can send it to Riley, and then
Yeah, I've already got it. I'm working on it.
no, you're
Oh,
okay. So
okay, okay, sweet. You got our emails. Yeah.
how CMP works. So CMP
Compare.
it pretty much subtracts it. So it's gonna subtract and so it's gonna subtract the second opcode and gets the from the EA from the first one to get to the result. So it pretty much it's not comparing or anything like that. It just pretty much subtracts like from the it subtracts the second one from the first opcode is what it does. So does that make sense? Kind of like how addition and subtraction sort of.
Yeah, I remember that I got that wrong. I think from the first quiz.
Yeah, it was actually from the first quiz. Good idea. Let's go
Yeah,
pull that. I'm gonna pull that one up.
because
That
I
way,
remember.
because
Yeah,
it's actually from the first quiz. Good guy. That was actually a good eye. I want to point
yeah,
that
because
out
it
as
was
well.
kind of tricky. Yeah, but good. Yeah.
Okay.
Where's the
No.
CMP at? Yeah, Mauve.
It should be toward the bottom. I think it says, what does the compare do? Or to, yeah, yeah. Wait, hold on. Go up. Because I remember.
No, but I remember this one. So it pretty much it's not really compare. It
Right.
subtracts the second operand from the first one, and it gets the results as well. So yeah, that's pretty much it. So we're gonna go back to the midterm. How to read a memory address.
Okay, here we go. It's uploading now.
Awesome.
I got it. I think I got it to work.
That's cool. So yeah. So yeah. So how to read a memory address? Let me look at that one. Try and see from your guys' lab to see like what to do, like for that question. Uh, no, that's not it.
See here.
I think it's just trying to say like how to read it. Like you start off pretty much from what we did from the EAX,
Yeah.
and I think that's what it is.
I
So
think it's okay. So okay, what's okay? The specific question is how to read a memory address. Password, let's search memory for the string. String is a memory. No, the memory address. I'm kind of just figuring out, okay, how to read a memory address. I mean, it's just kind of trying to figure out. I think it's in the debugging PDF. Okay.
okay. So now we're gonna go to the next one, logical operators. So
Logic operations, that being the and or XOR or not, I believe.
yes,
I'm seeing that
yes,
from just this intro to assembly basics PDF. You can find that in.
yes.
Um,
The logical
yep,
operations. Yep, that's
yeah.
the one, the very last one. Yeah,
Page 14 of the assembly basics, if anybody wants to look.
very good. Yeah, it's from the um very last page, and or X not. So DRM. I'm gonna see what that is.
Do people take care of the animals around this?
Oh, that's digital rights management.
Yeah, I was gonna say do-do-do.
I have to know what it does. So
Digital rights management. So, well, drivers for years, some of them they be kids. Digital rights management. You look at the
it's like an exploit that's like
yeah, it says just in I think it's like page. I just searched DRM and the textbook thing, the textbook PDF says it just pulls up. Rootkits have been developed as drivers for years. Some malware has adopted rootkit strategies, embedding themselves in a kernel. DRM software often has drivers that contain vulnerability as opposed to those discovered. This single software shareware. Okay.
that's like where they use like something that's not allowed into any type of software. So yeah. So
So basically, yeah, the DRM with respect, I believe, to what we were doing, the basically the runtime patching and making a registered and an unregistered registered.
mhm.
Okay.
Yeah, it's very much unauthorized use to like I'm not sure what the word is. Okay, let's go to the next one. LEA, load effective address. Um, and pointer is a memory address. Hexadecimal.
You're gonna let us use a calculator for that, right?
Yes, he is
Yes.
allowing it. You do not have to do that by hand. Hex to decimal. So we're going to do this. 74 from hex becomes 116 to decimal. We're going to know what bits, bytes, words, and D words. So we look back from our first page. See right here. There's 1 bit. Byte is 8 bits equal 1 byte. 1 word equals 16 bits. And D word is 32 bits. So the same thing that happened from the first lab assignment should help you with that. So ZF, CF, and OF. Those are the types of flags.
Alright, there's part one.
I got on the Discord now?
Yep.
Awesome. Thank you. All right, so Z flag, we go look to that one. Where the flags go? The flags. Okay, I found the flags. So Z flag is used for most for cracking, and this is set when the result is non-zero, and it will be cleared if it is zero. No, sorry, wrong one. So
And where did we find that?
if you look on the flags, like from the assembly thing,
So from assembly basics?
yes.
Yeah, that's right. Jumps. Let me see. Ah,
So it's pretty much used for all cracking. So
okay.
so it's pretty much they'll say like this thing will be at zero, and it'll be at non-zero as a result if it cracks. So and for Z flag and for um O flag, it pretty much it's rarely used in the cracking attempts. It's like set at one, and it'll change the highest bit of the register for operations. So
Okay.
the C flag. Oh, sorry, I skipped C flag. So this is only used at 1%. So if you add a value to register, then it gets bigger than a FFF, or if you subtract the value, so that a value gets smaller than zero. So, but you can use that for your exam. So that of one for the Z flag, C flag, and O flag is pretty much used for the exam. So the we also have to know what the hardware and software breaking points. So um, we have to know like which one's the software breaking point. So one of them is gonna be like it's from the opcode. So it's zero times CC, which is a software, but we need to know one for hardware. And there's like four um hardware breaking points as well.
Oh yeah, basically from that Ollie debug.
Yes. Mm-hmm.
Yeah. Some of the software breakpoints essentially we did whenever we loaded the application in and did kind of like the view, I believe, and we looked, yeah, I remember that from the instructions. Basically, I think a lot of those answers would be from there, kind of
Mm-hmm.
explaining them.
How does stack work? He said something like when you push something to one thing to another. I remembered he said that in class. Do you remember what I'm talking about from the first day? When you push something, how stacks
Uh,
work? Done this one right here.
Yeah, yeah, I vaguely remember whenever when he was essentially talking about um uh yeah, I think it was in the recording trying to use the grocery store example.
Hmm. When you push something, you're gonna go, you're gonna put it on top of the stack. You know what I'm saying?
Yeah, it's like basically finding the milk with the best expiration date and pulling it
Exactly.
out and putting it up front.
Exactly. So that's what he said in class. So how to push, like, stack, like, where do you put it? You're not going to put it
Right.
underneath it. You're going to
Yeah,
put
you
it on
got to put
top
it
of
on
it.
top.
Exactly. Do you remember when he said that in class?
Yes.
Awesome. Perfect. So we're on the pre-test versus, um, excuse me, post-test. Well, I know pre is something like when you look at the root word pre, that's something you're done before. So
Free, and then I'm, yeah.
so that pre-test is something that they use to test before it is executed. And post-test is like when you push the results after the body is executed. So pre, think of it like pre, like you do something before, that's pre. That's something you're done before something is executed. Post is when you're done after.
Kind of like testing it in like almost like you would test something in
Ollie
like a
debug
virtual
or something.
machine or something like that
Yes.
before you
So
push it
we
out to the
think back from
public.
Ollie debug, like when you test something before or IDA. Does that make sense?
Right.
Okay, so we're gonna go to Big Indian and Little Indian. Now I remember this one very, very well. The Big Indian is the greatest significant my recording will end in 10 minutes, so we're almost done, so let's make that one count. So
Yeah, I remember there was a little Indian
yeah, he posted
question that
something on the okay, so least significant byte is stored at the lowest address. So the Big Indian is the most significant byte. That's the one.
yeah, little Indian, I believe it's whenever it's like everything is reversed, I believe.
Yes,
Yes. You have like the hex string or something like that, and then you kind of you basically flip it.
exactly. So Big Indian is where the most significant one that'll happen. So
So Big
well, so
Indian, the most significant value is stored last.
yes,
Okay.
yes. So pretty much like you see something that gets switched. Like let's say front goes to back. That's the Big Indian, right?
You see here.
Yeah, the highest number gets
And if
stored
it's
at
so
the
if it's
end.
so the least byte will be at increasing, so it's going to be at the first one. So bytes are stored and increasing in significance. So it's pretty much leading. So it's pretty much leading. Whereas the other one, the first for big endians, just got all the way to the back.
Yeah, so it would be like if you had a line of numbers, big Indian would be like 0, then 1, then 2, then 3, then 4, whereas little would be 4, then 3,
Four,
then
then
2,
three.
then
Yep. Absolutely.
yeah.
Okay.
All right. Flirt. That's something we did in IDA.
So that might just be going back and watching that video.
Or I can look it up. If anyone wants to look to see what it does on Flirt.
I plan on probably just watching all of the videos that he's made.
Let me see.
Oh, there it
Alright.
is. Library functions and recognition of technology. Okay.
Okay.
It helps identify like functions pretty much. So it's a fast library identify and technology. So it pretty much it just identifies the type of functions that it does.
Yeah. Okay. Okay. So even in the book, it says, as you can see, IDA has not reanalyzed all the important functions. This happens because the flirt signatures with IDA typically run over the code.
So it's pretty much identifying it.
Yeah, it's like a signature.
Exactly.
Yeah.
So we're gonna go to push. Okay, so it pretty much stores the data so that it can be treated later. So okay, so it decreases the
It-
stack.
yeah.
Um,
Push is the opposite of pop. It stores a value on the stack and decreases it by the size of the operand that was pushed. So that ESP points to the value that was pushed. Pop loads the value of byte, word, double word, pointer, and puts it into destination.
ah,
Additionally, it increases the stack by the size of the value that was popped onto it. So push reduces the value on the stack. It looks like pop would increase. And on page 13 of the assembly basics.
so yeah, push is like something that we did based on what Dewey was talking about. The same thing, like how it'd be on top of it.
Yes.
So that's pretty much the same thing. So what he said in class, when you push something, you're not going to put it on the bottom of it because it doesn't make sense. You know what I'm saying?
Mm-hmm.
Because
Yeah,
how you gonna?
I plan on having the reverse engineering lab 1 PDF open since we're allowed notes.
Yeah. So
And
pop is
that's
pretty
good.
much pop is just I think pop is just the bottom of the stack, I believe.
See. Yeah.
Increases the stack by the size.
Yeah, ESP points to the stack of a current process, the stack in that place where data is stored for more yeah. Yeah, so I guess when you're dealing with, if anything, there's probably examples. It's dealing with ESP.
Okay. So it's pretty much
Precedent.
like
Yeah.
pops is stacked back into EAX. So what it's saying like pop is the stack value back into EAX. So it's taking this one. So it's popping it back into this thing, which is going to be the answer.
Okay.
So I think it's like in the push. So it's pushing this one and it's going to go back into the so it's pushing this one, it's going to go back into this thing. Is what it does. Does that make sense?
Yeah.
Yeah. So What? Moves from the. Okay, I see. Okay. Okay, so now we're gonna go to the last one. Oh, so we got it all.
Yep.
Yep.